Hi, I'm going to get this thing back to where I want it to be. There we go. I'll give you a brief little lecture on the session 2 material. Now, if you caught the opening video for this chapter, we'll be in chapter 1, the session 2. Session 1 was pretty much, had you do some research on the how wide wireless is being used and a little bit about on potential careers. So Session 2 is the start of looking at your textbook. You'll be in the textbook for chapter pages 1 to 10. Chapter 1 is a little bit long, has a lot of definitions and terms, but it is the foundation for the whole class. So we'll spend 2 weeks covering the material in chapter 1 so that your first exam for that material will be there. So let's take a look at what's going on in this chapter. Now, in this chapter, the first part of it, we're going to look at just signal characteristics. And basically, there are 4 characteristics that we'll be worried about or concerned about in this class: frequency, amplitude, phase, and wavelength. And we'll talk a little bit about what their definitions are and a little bit of how they may be used. Now, radio frequency, what it basically is, it is a portion of the electromagnetic spectrum that is used by the 802.11, the IEEE 802.11 standard. That IEEE 802.11 standard is used by Wi-Fi to certify devices that to make sure that they meet the standard. But it is a portion of the electromagnetic spectrum that we used. And as you can tell from the chart below, it's a fairly large range of radio waves, but we don't use all of it. Basically, as far as Wi-Fi networks are concerned, we use radio waves in the microwave frequencies between 300 megahertz and 300 gigahertz. Now, most of our frequencies we stay in is in 2.4 gigahertz and 5 gigahertz. There are a couple other that are used. There's a 60 gigahertz, and then there's a sub 1 gigahertz range that are also used, but for the majority of what we do, it's 2.4 and 5. Now, the question is, how is radio frequency used in wireless networks? Basically, it uses the RF waves as carriers that can have data applied, that we can change the way that wave is to represent data. And there are basically 2 that are used the most. Amplitude and phase are used the most in Wi-Fi networks. And frequency is another one, but there are no networks out there using it. But just know there's amplitude shift keying, so I'm going to change the carrier wave based on changing the amplitude, make them stronger and weaker. There is phase shift keying, which says I'm going to compare 2 signals and I'm going to kind of change their positioning either by 45 degrees, 90 degrees, 180 degrees, 360 degrees, whatever the case may be. As I change the relationship to the waves, that is a way we can modulate it to determine, to actually make it a 0 or 1 based on how those changes are made. And it says frequency shift keying, yeah, I can make the frequency higher or lower, but for the most part, it is not used in any Wi-Fi network. And just keep in mind that modulation is the process that we're manipulating these RF waves to represent digital data. Now, some of the basics of this, you've got a whole series of waves here. You've got the frequency. And basically, what is that? That is how fast is that signal going over time. the lower the frequency, the longer the wave, the shorter the frequency, the higher the frequency, the shorter the wave. As you can see from the phase, here I've got a wave starting one, and all of a sudden I flipped it when it started the next wave, a certain percentage off from the previous. So it's comparing, anything with phase shift is comparing one wave to another, and then based on what those changes are, whether it's, right now maybe that representation of having a 180-degree shift between those two phases is difference between a 0 and a 1. You could shift it 90 degrees, 45 degrees, 100, a lot of different ways, but it's relationship to the previous wave. How does that phase change? Now, wavelength is basically just the length to complete one wave. It can be long, it can be short, but just know that the basic concept of that is just that it's the length of one wave. And then amplitude is used to define the strength of a wave. The higher the amplitude, the stronger it is. The slower it is, the weaker it is. Now, as waves go on, you're going to see in the next section, what does the environment do to these different waves. But just know that from these 4 characteristics is the foundation of everything we're going to do in this class, as far as to be able to put data on a RF wave and you send and receive it. So hopefully that gives you a real brief summary. I may post some other videos for your reference on some of those, and I was trying to find a simulator, and I might still find a simulator to let you play games with it, and if I find one, I'll post it. If you have any questions, let me know. Talk to you later. Bye-bye.